Good afternoon. So we have a small group here today, so we can be a bit casual. My name is Casey Ng. I'm the Audio Marketing Director for Cadence Design. And today I want to talk about TWS applications using RISC-V and HiFi DSP. So as we all know, TWS, or True Wireless Stereo Earbuds, is one of the fastest growing consumer audio products. Since the first Apple AirPods, it grew from 60 million units annual shipment in 2017 to almost 400 million units as expected this year, and could reach 600 million units in 2027. We are also seeing that the audio features are getting more sophisticated. Advanced audio features such as using voice control for voice assistance, speech enhancements like beamforming, wind noise reduction, active noise cancellation, so-called ANC, for killing environment noise, and also new and improved audio codecs like LC3 are becoming common features in current and future TWS applications. If you are not already familiar with Bluetooth audio, in July of this year, the latest version of the Bluetooth audio specifications, known as Bluetooth LE Audio, has been finalized. Bluetooth LE Audio brings in many new capabilities, and more significant ones are LC3 codec support that offers better audio quality with lower latency, and a new broadcast audio sharing protocol known as Oralcast. Transition to the LE Audio takes time as of today. There is no LE Audio source device. So during the transition period, Bluetooth devices must be so-called dual mode that support both the classic and the LE Audio. We expect dual mode devices to dominate the market in the next few years. The gray bars are showing the dual mode products, and if you see the light blue bars on the top are the LE Audio only devices. So the quantities are very limited, and most of the new SoC products that we are going to see in the market supports dual mode. While the TWS earbuds are very small and very tiny, consumer demands longer battery life, better performance, and more features. So there has been a lot of advancements in components, software, etc., to support the whole TWS growth. Today's better TWS could use up to 3 microphones per side, and some designs use other voice sensors technology such as bone conduction pickups, we call it VPU, that can help mitigate noise. We are also seeing that a lot of sensors like IR for wear detection, sensors that can monitor heart rate, and also built-in accelerometer and even IMUs that can be used to detect head movements or support gesture user interface. Different forms of control interfaces to support touch, slide, squeeze, etc., and also new generations of transducers such as MEMS speakers are coming on board. So to support all the new advanced components, many new software are coming on to support these features, and everything needs to be energy efficient, because one of the limiting factors is that the size of our ears still remains the same. And we cannot make TWS bigger because it will not fit. So consumers expect more features, longer battery life, and still fit well into your ear. So a very simple audio processing that's happening when you're talking on the phone in today's TWS is already quite involving. A voice is picked up, as an example here, voice is picked up by 2 beamforming microphones. In the classic beamforming algorithms, the microphones are lined up to emphasize picking up sound from a specific direction and rejecting noise that are adjacent to the microphone array. And in this case, we also added ANC, active noise cancellations, which is becoming very popular. The active noise cancellation use feed-forward and feedback microphones to pick up ambient noise, and then the algorithm generates so-called the anti-noise, that is 180-degree out of phase signal, which can be mixed into the streaming audio or music signal to cancel out the ambient noise. So this is just one example of audio processors that happens within HFP, so-called the hands-free profile. If you see on the right side, the stacks of Bluetooth profiles, HFP is just a specific profile that is engaged when a phone call comes in and the microphone has to pick up voice. Within the whole dual mode complete solutions of a Bluetooth, if you see on the very, very left side, HFP is just one of the profile out of the many profiles that the classic Bluetooth has to support. And the right side are all the audio framework the LE Audio has to support today. So the dual mode Bluetooth 5.2 solution has to support all of the above profiles and audio frameworks. As Bluetooth specifications are getting so complex and with rapid revisions, to be more future-proof, we want to put more features that can be pushed in firmware update to minimize RTL changes and so-called to future-proof the design. So we propose TWS platforms that uses RISC-V cores and the HiFi DSPs. The RISC-V cores can be used for application processing and baseband controller. The HiFi DSP cores are used for real-time audio processing when needed. This is an example of a high-performance platform. We have a RISC-V with a 4-stage pipeline running the application processor and a smaller 2-stage pipeline RISC-V as a baseband controller. The HiFi 1 core, which is on the top, the green block, it has very low power, and we can use it to run ANC and other always-on audio features. Also, when you are playing back simple music streaming, we can use the small core, the HiFi 1 core, to decode audio streams. In that case, we can save battery life and extend battery life and save power. If a more complex audio functions are required, such as a voice call processing with AI or ML-based noise cancellations, we can direct that audio task to the higher performance HiFi 4 or HiFi 5 core. The second example shows an architecture that can target long battery life design. The AP and baseband controllers are pretty much the same. But for a simple entry-level TWS that has to focus on lowest cost and longest battery life, we can utilize just a single HiFi 1 core to do all the audio tasks. If additional audio task has to be done simultaneously, such as ANC, we can add a second HiFi 1 core. The AP is a RISC-V 4-stage pipeline. It manages and doing the housekeeping, Bluetooth protocol stack, and profiles. The communication processor controls the hardware Bluetooth modem, and all the processing can be handled by the HiFi DSP. This is another perspective that shows the hierarchy of the Bluetooth operations. The AP hosts the application profiles and the services down to the HCI level, and then hands over to the baseband controller, which then manages the link layer and the interface with the physical layer, i.e. the radio and the analog end. Here's the high-level comparison of different HiFi DSPs. HiFi 4 and HiFi 5 are the high-performance DSP cores that are suitable for complex audio applications The HiFi 5 having the highest performance and is very ideal for the current and future AI-based use cases. HiFi 1 is the newest addition to our HiFi family. For TWS application, HiFi 1 can cover all the necessary audio features in a dual mode applications and yet provides the best in class energy efficiency. So Tensilica HiFi DSP is currently the #1 audio processing platform, and as of today, we have over 155 licensees and more than 180 ecosystem partners. With over 1.5 billion devices shipped annually, HiFi DSP cores are in almost every consumer audio use cases. Tensilica provides comprehensive DSP tools and software. With many of our partners, they can provide algorithms and different levels of software integrations to help our customers. For TWS Bluetooth integrations, we provide the widest availability of audio codecs, and many of our partners specializing in front-end voice and speech processing can quickly help put products into the market. I also want to mention that we have partners such as Mindtree that can provide Bluetooth software and hardware IPs that work closely with Tensilica, and we can help bring Bluetooth SoC to the market quickly. This is actually a partial list of partners that are active in the TWS and hearable space. If there's any specific interest and use case, please feel free to contact myself or any members of Cadence team after the presentation. So that concludes my presentation, and perhaps we have some time that I can take some questions and we can have some discussions here.
I've got a microphone back here if anyone's got a question.
If not, thank you for coming, and you can talk to me privately after the session if you have anything to talk to or any of the Cadence team that's sitting in the audience. Thank you.